All right, physics students, today we are going to work on homework number 1. This is our first calculations homework that we're going to do, and it's all just using the equation that I gave you in the notes yesterday. Velocity equals delta x over t. All right, so number 1, we're going to do 1 through 6. Number 1, it says Heather and Matthew walk with an average velocity of 0.98 meters per second eastward. If it takes them 34 minutes to walk to the store, what is their displacement? So we write first what we know. It says the average velocity is 0.98 meters per second eastward. All right, then it says it takes them 34 minutes to walk to the store. 34 minutes is a time. And the question is, what is their displacement? So I write delta x equals question mark. All right, now I want to solve for delta x. This is the equation I have. So I'm going to rearrange that equation to solve for delta x. So v equals delta x over t. So let's get rid of t here, multiply both sides. And so let me just rewrite that a little bit more neatly. Delta x equals v times t. And now I can multiply 0.98 meters per second times 34 minutes. Now, there's a problem here. Minutes and seconds are obviously not the same. I have to convert minutes into seconds in this case so that we're comparing apples to apples here. So I need to convert minutes into seconds, and I know 1 minute is the same as 60 seconds. And minutes will cancel out minutes here, seconds will cancel out seconds. I'm going to be left with meters, which makes sense because I'm looking for delta x. Okay, so I'm going to take the calculator out here since I don't really think I can do this one in my head. And so that's going to be 0.98 times 34 times 60 equals 1,999.2 seconds. I'm sorry, not seconds, meters. So I'm just going to round that up to 2,000 meters. All right, anytime we do problems, I want you to go through the 5 problem-solving steps. I mentioned that all of our tests, when you do a problem, I should say most of them are going to be worth 5 points, and these are the 5 points. The first thing is you read the problem and you write down what the known variables are. Number 2, you write down what the unknown variable is. This is the thing you're looking for. I don't really care what the order is here, just make sure you have both of them. Then I want you to write the algebraic equation, which is the equation with no numbers, just letters. Then I want you to show your work or plug and chug, and then I want you to answer with the correct units. So that is where the 5 points come from. If we take a look at number 1 here, you can see that I did that. We knew from the problem that the velocity was 0.98 meters per second east, and we knew that the time was 34 minutes. So that's step 1. Step 2, it asks for the displacement. So this is my unknown. I write the variable for my unknown is set equal to the question mark because it's unknown, right? Then I wrote down v equals delta x over t. This equation here, I wrote it here. And then I rearranged it to get it into a form that I want. So this is my algebraic equation. Then I plug numbers in. This is where I say plug and chug. And then calculator magic, we get our final answer. So that is a 5-point problem. I would get 5 points of credit for that. If all I saw was this answer, 2,000 meters, that would be -4. So that'd be 1 out of 5. Okay. This is a way for you to show me how you know how to get the right answer. Okay, number 2. Number 2 says, if Joe rides his bicycle in a straight line for 15 minutes with an average velocity of 12.5 kilometers per hour south, how far has he ridden? Okay, so it says he rides in a straight line for 15 minutes. So time equals 15 minutes. Average velocity is 12.5 kilometers per hour. And the question is, how far has he ridden? All right, so again, it's the same thing that we did up here, looking for how far you go. One thing that we can take care of beforehand is we notice we have minutes here and we have hours here. So you don't really talk about kilometers per minute, but kilometers per hour is pretty standard. So 15 minutes is the same as how many hours? Well, it's a fourth of an hour, right? So that's 0.25 hours. Now, I could have done that mathematically if I wanted to, but I thought maybe doing that one, since it was simple in our head, that'd be fine. Okay, so same equation as before. Delta x equals v times t. And that's going to be 12.5 kilometers per hour times 0.25 hours. And again, notice h and h are one's on top, one's on bottom, so they cancel out. And then let's get out the trusty calculator here. 12.5 times 0.25 equals 3.125 kilometers. I'm just going to round that to 3.13 kilometers. All right, moving on to number 3. Number 3 says it takes you 9.5 minutes to walk somewhere with an average velocity of 1.2 meters per second. And then the question is, what is your displacement? So this problem is exactly the same as number 2. The only difference is the numbers are different, but the equation is going to be the same. Delta x equals v times t. This time I won't convert first. V is 1.2 meters per second, and time is 9.5 minutes. Okay, so again, seconds and minutes don't cancel each other out, so we have to change minutes into seconds. So 1 minute is the same as 60 seconds. So minutes cancel minutes, seconds cancel seconds, and I go 1.2 times 9.5 times 60. And that's 684 meters. All right, let's go to number 4. Number 4 says Simpson drives his car with an average velocity of 48 kilometers per hour. So V equals 48 kilometers per hour. All right, to the east. Guess I haven't been paying attention to direction here. How long will it take him to drive 144 kilometers on a straight highway? So how long? Now our time is the unknown, and we're given a displacement of 144 kilometers. Okay, so how do we figure out what time is? Well, I go to my original equation that V equals delta x over t, right? And we're going to solve it for time, so we want to get time all by itself. So we have to get it out of the denominator. Right now it is dividing, so let's do the opposite and make that a multiplying thing. So t times v, t over t, those cancel out. And now I'm going to divide by v on both sides so that t can be by itself. So let's rewrite this. T equals delta x over v, and that's going to be 144 kilometers over 48 kilometers per hour. Kilometers are going to cross out kilometers here, and hours will come up to the top for time. So what is 144 divided by 48? It is 3. So that's 3 hours equals our time. All right, moving on to number 5. Okay, number 5 says that look back at item 4. How much time would Simpson save by increasing his average velocity to 56 kilometers per hour to the east? So now the distance is still the same. And the velocity has changed to 56 kilometers per hour. And it says, how much does the time change compared to number 4? Well, we have to know what the time is right now. So, same equation as before. T equals delta x over v. I'm not going to redo that since I already did it. So delta x is 144 over 56. 144 divided by 56 equals 2.57 hours. Kilometers, cross off kilometers, the hours comes up to the top. Okay, so that's how much time it takes now. So the question was, how much less time is that than we had in number 4? Number 4, the time was 3 hours. Okay, that was in number 4. In number 5, it's 2.57. So what's the difference? Well, 3 minus 2.57 is 0.43 hours. So that's the answer for number 5. And finally, number 6. Number 6 says a bus travels 280 kilometers south along a straight path. Okay, so we have a displacement of 280 kilometers south with an average velocity of 88 kilometers per hour to the south. The bus stops for 24 minutes. Then it travels 210 kilometers south, so we have another displacement with an average velocity of 75 kilometers per hour. So first of all, it says, what is the total time? Okay, well, time, there are 3 times here. There's the first part of the trip. This is T1. There's the resting time, T2. And then there's the third part of the trip, T3. So we have to add those 3 things together to find out what our total time was. Well, how do I find out what T1 was? It's going to be just like we did for number 5. It's going to be delta x divided by v. So this is going to be T1 equals delta x1 over v1. It's going to be 280 kilometers divided by 88. Kilometers cancel kilometers, hours comes to the top. Bring out my calculator, 280 divided by 88 equals 3.18 hours. All right. Time 2 is 24 minutes. Now we have to have that in hours, so x hours equals 24 minutes. And there are 60 minutes in 1 hour. Minutes cancel minutes. And I go 24 over 60 equals 0.4 hours. Okay. And then time 3, we'll do just like we did time 1. T3 equals delta x3 over v3 equals 210 kilometers divided by 75 kilometers per hour. Again, same thing as before, just different numbers. 210 divided by 75 equals 2.8 hours. So what's the total time on the trip? Total time on the trip equals T1 plus T2 plus T3 equals 3.18 hours plus 0.4 hours plus 2.8 hours. And that's going to be 3.58, 5.58, 6.38 hours. So that's part A. Part B says, what is the average velocity for the total trip? So for the total trip, our velocity is the total displacement divided by the total amount of time. All right. Well, what's our displacement? We actually have two displacements here. We have 280 plus 210 for our displacement, and our time we just figured out was 6.38 hours. So add these two together, that's 490 kilometers over 6.38 hours. And then do the math. 490 divided by 6.38 equals 76.8 kilometers per hour. Now check your answer here. Notice that this velocity is not the same as the velocity that was traveled during the first part of the trip or the next part of the trip, but this rest time, when there was no velocity, lowers definitely to 88. It's actually still a little bit faster because most of the trip was done at a higher number, so it's landed this time somewhere in between 75 and 88. It wouldn't have to, though. If he rested for 3 hours, then it'd be well below that. Okay, that is it.